In this concept, we're going to look at solving quadratic equations by factoring. So in the previous concept, we talked about solving quadratic equations by graphing, but graphing is not always a practical means of solving quadratic equations, especially, for example, on a test where it's, you have limited time and you may not even have a calculator, in the non-calculator section of the SAT. So in which case you may not want to solve it by graphing because it would be time consuming. A better way, though, is, in this case, a better way is factoring, algebraic method. So the solutions of a quadratic equation are called the roots of the equation and can be found by finding the zeros of the quadratic equation. So as we mentioned, a quadratic equation can be solved by graphing, factoring, or completing the squares, or using the quadratic formula. In this concept, we're going to talk about factoring. Okay. So, as you can see in this picture, we talked about the x-intercepts in the previous concept, right? So the x-intercepts are essentially the solutions of a quadratic function, and they are found by setting the y value, which is the function itself, right? So you have some f of x or y, equals something, right? Some x expression, right? X squared plus, 2x, minus 5, whatever, just an example. So you find the zeros by setting the f of x or the y equal to 0. So you have 0 equals this whole expression, right? So x squared plus 2x minus 5, and then you solve for these x's, right? And then the results you get are these x-intercepts, or essentially the roots of the function. Let's look at some examples. Solve the following quadratic equations. Example 1. F of x equals x squared minus 4x. In this case, we want to factor. So first we set the f of x equal to 0. Right? So we have 0 equals x squared minus 4x. Then we can factor out an x, right? So find the greatest common factor here. We take out an x from, the x squared and 4x. So we have x times x minus 4, okay, equals 0. Using the zero product property, right, x is either equal to 0 by itself, or x minus 4 is equal to 0. So x equals 0 or x minus 4 equals 0, which gives us x equals 4 for the x minus 4 equals 0, and then x minus 0 is just x minus 0. So these are our two roots, 0 and 4. So our solution set is 0 and 4. Okay. Example number 2. So we have f of x equals 5x squared minus 5x minus 60. Again, we set f of x equal to 0. So we have 5x squared minus 5x minus 60 equals 0. Find the greatest common factor. Again, the goal is to keep simplifying this until you isolate the x's and can use the zero product property, to determine the roots of x. So 5x squared minus 5x minus 60, greatest common factor is 5. So 5, 5, and 5, right? 60 divided by 5 is 12. And then we take out this 5 and this 5. So we have 5 multiplied by these parentheses, x squared minus x minus 12 equals 0. So this is 5. It's not a variable, so I can basically get rid of it. I can't, 5 is not going to be equal to 0, right? In the previous one we had x, so 0 was a root. But this is 5, so we can actually get rid of it, right? And we do that by essentially dividing both sides by 5. So this whole thing divided by 5, then the 5's cancel. This side divided by 5 is still 0, right? So now I have just the parentheses, x squared minus x minus 12 equals 0. We factor this further, so we get x and x, right? X squared breaks into x and x. And then we have minus 12. So again, this is, you factor this, so this, 12 factors into, 12 times 1, 6 times 2, or 4 times 3, etc. And then, again, you need to pick a pair which, when added or subtracted somehow with some combination of signs, will give us minus 1, right? So 12 and 1, there's no way they'll give us minus 1. So these don't work. 6 and 2, there's no way that they can be added or subtracted to give us minus 1. So these don't work. 4 and 3 can give us minus 1. With what signs? Well, so if we added, if we do minus 4 plus 3, that gives us minus 1, right? So our two factors of minus 12 are minus 4 and plus 3. So x minus 4 and x plus 3 equals 0. Using the zero product property, we have x plus 3 times x minus 4 equals 0. So we have x equals, so from this pair of parentheses, we have x equals minus 3, and from these parentheses we have x equals 4. So our solution set is equal to minus 3 and 4. These are our two roots for this equation. Okay? Example 3. X squared minus 1/4 equals 0. If you look at the 1/4, you can actually separate it into 1/2 times 1/2, right? In which case the 1/4 is really a square of, a half, right? So this is essentially a difference of two squares. So x squared and then a half squared, which is 1/4. So again, just so you can better visualize it, you can write it in this form. So x squared minus 1/2 squared, right, equals 0. So 1/2 squared is 1/4. So this can be factored to this expression, right? So remember, difference of two squares. So a minus b, a squared minus b squared can be factored to a minus b times a plus b. Okay? So we get x minus 1/2, x plus 1/2 equals 0. Okay? And now, using the zero product property, we have, so x minus 1/2 equals 0, or x plus 1/2 equals 0, in which case we have x equals 1/2 or x equals negative 1/2. So the solution set is, again, negative 1/2, positive 1/2. Okay? Another way we could have done this without, the factoring is we could have just said x squared minus 1/4 equals 0. So if we bring the 1/4 to the other side by adding a 1/4, to both sides, right? So you get, these cancel out, and then you get a 1/4 on this side. So we have x squared equals 1/4, right? In which case, if we take the square root of both sides, we have to take the plus and the minus values of the square root, right? So we have x equals plus or minus 1/2, which is exactly what we had up here, right? Plus and minus. Okay, so this is just another method that does not involve going through factoring. Example 4. 9x cubed equals 81x. If we bring the 81 to this side, again, the goal is to be able to simplify and isolate the x's. So we can then find the zeros. So then we get 9x cubed minus 81x equals 0. The greatest common factor of 9x cubed and minus 81x is 9x. So we factor it out. So we have 9x and then times what's remaining is x squared, and then here what's remaining is minus 9 equals 0. But x squared minus 9 is essentially a difference of two squares. So what I can do is I can break this down or factor this to x minus 3 times x plus 3. So now I have 9x times x minus 3 times x plus 3 equals 0. So I need to actually take all of these roots. Okay? So either 9x equals 0, or x minus 3 equals 0, or x plus 3 equals 0. So x equals 0, or x equals 3, or x equals negative 3. So my solution set includes all of these numbers, 0, 3, and negative 3. Okay, and obviously we can plug these back in, to confirm that they are indeed solutions. Example 5. So we have x squared minus 1/2 x plus 1 over 16 equals 0. So this trinomial is actually a perfect square. So what we could do is we can convert it to a perfect square. So x squared minus 1/2 x plus 1 over 16 equals 0. This is, so 1 over 16 is essentially a quarter squared, right? So, and then this is 1/2 is 2 times a quarter, right? So remember the form for perfect squares, right? So we can convert this to x minus 1/4 all squared equals 0. In which case x will have to equal 1/4, right? So my solution set is 1/4. Example 6. X squared minus 4x minus 21 equals 0. So if we break this down, if we factor this, we have, so the x squared factors to x times x. The 21, again, follow the same procedure that we always follow to factor the third term. So 21 is either 21 times 1, or it is 7 times 3, and that's it. So now which of these two can add or subtract in any different way to give us minus 4? Well, it's definitely not 21 and 1, so it's got to be 7 and 3. How can 7 and 3 give us minus 4? Well, if we had minus 7 plus 3. This is 3, sorry. Right? So our two factors for minus 21 are minus 7 and plus 3. So we have x minus 7 and x plus 3 equals 0. In which case we have x minus 7 equals 0, or x plus 3 equals 0, so x equals 7 or x equals negative 3. Okay, so this is our solution set, negative 3 and 7. Okay, and again, it is always wise to use these and plug them back into the equation and make sure that you do get 0, right? Make sure the equation checks. Usually a quadratic equation is given to solve in order to find the roots, okay? But a quadratic equation can also be written by having the roots given. Let's look at what this could look like. So write a quadratic equation with minus 4 and 5 as the roots. In this case, we would use this generalized equation, x minus p times x minus q equals 0, to find our actual equation having these roots. So x minus p times x minus q equals 0. Substitute the roots for p and q. So remember, since this is x minus p, so if p is negative 4, right, so when we substitute negative 4 for p, we get x plus 4, right, because it's x minus negative 4, which is x plus 4. And then q is 5, so x minus 5 equals 0. So x plus 4 times x minus 5 equals 0. Then we can FOIL these using the FOIL method, right? So x times x is x squared, plus 4 times minus 5 is minus 20, plus 4x minus 5x is minus x, right? So this is our quadratic equation having minus 4 and minus 5 as the roots. Okay? Sometimes the question will ask to find the solution for the quadratic equation, and in other times it will ask to find the intersection with the x-axis. But essentially, these two things are the same, right? The intersection with the x-axis is the solution for the quadratic equation, okay, or the roots. So both of these things are the same. Okay? Here's an example. What is the intersection of the graph of f of x equals 3x squared plus 14x plus 8 and the x-axis? So again, this is essentially asking us to find the roots of this quadratic equation, or the solution of this quadratic equation. So to find the x-intercept, we set the f of x equal to 0, or y equals to 0, right? Then solve by factoring. So 3x squared plus 14x plus 8 equals 0. Factor these out. So 3x squared factors to 3x times x. 8 factors to, again, either 8 times 1 or 4 times 2, etc. So we need the two numbers to add up to 14x, especially including this this factor here, the 3. So it's definitely going to have to be 4 and 2. So let's try 4 and 2. Since we have a plus here and a plus here, we know the signs are both plus, so that's easy, right? So we could check back to see if we get back to this original equation, right? So plus 2x, we just need to check the middle term. So plus 2x, and then plus 4 times 3, plus 4 times 3 is 12, so plus 12x. So plus 2 plus 12 is plus 14x. So this checks. Okay? From here, we use the zero product property, which gives us 3x plus 2 equals 0, or x plus 4 equals 0. Solve for x, so we get x equals minus 2/3, or x equals minus 4. Okay? Sometimes the expression, an expression such as x to the 4th plus 12x squared, oops, let's fix this, x to the 4th plus 12x squared plus 4 can be written in the form au squared plus bu plus c, as follows. So the whole point is, if you have, if the largest exponent is not 2, right, you can convert it to something with the largest exponent being 2. In this case, the largest exponent is 4. So if we need to make it 2, we need this to become something, so x to the fourth can be written as x squared squared. So then we just take this x squared and we write something else for it. Let's say u. In which case we'll have u squared, right? So x to the fourth becomes u squared, with u being x squared. Again, the goal is to describe something that does not look quadratic, to describe it in quadratic form. Okay, to help us in solving a quadratic equation. Okay, so again, in this case, what we did was we let u equals x squared, replaced x squared with u in the expression, and then we rewrote the expression as u squared plus 12u plus 4, as opposed to x squared plus 12x squared plus 4. Okay, this new equivalent expression is said to be in quadratic form. Okay, and we'll see how this can be useful in these examples and in future concepts. So let's look at these examples. Write the following in quadratic form: 16x to the sixth plus 256. So this is going to give us, so again, the largest exponent is 6. To write it as something that is going to be quadratic, we could have x cubed squared, right? So x cubed squared is x to the sixth. In which case, we would need x to the third to be our new variable. So we can use, again, u equals x cubed, x to the third, and then we would have, instead of x to the sixth, we would have x to the third squared, right? And then we can plug in u for the x to the third, which is going to give us 16u squared, right? So this is this square sign, and this is the u, right? And this 16 can remain the same, and the 256 can remain the same. So now this is equivalent to this, but in quadratic form, and with u equaling x cubed. Okay? Let's look at this other example. 18x to the 8th minus x squared plus 12. So to write this in quadratic form, the x to the 8th would have to be written as x to the 4th squared, right? So our u would have to equal x to the 4th. But look at what happens if we write this in quadratic form, but then if we try to write the middle term in quadratic form, we're going to have to write something like square root of u, right, to get the x squared, right, because u is x to the 4th. So to get x squared, we need square root of u, right, or square root of x to the 4th, or x squared. So if we need to do something like this, then this cannot be written in quadratic form, right? We can't have this. So the answer is that this equation cannot be written in quadratic form. Okay? So now we have some exercises. Please pause the video, work on these, and come back for the solutions. Okay, let's look at these. So solve these by factoring. So x squared minus 16 equals 0. Remember the remember the trick that we saw? If you see something like this, what you could do is right? So factor or eliminate these, bring the 16 on the other side. So we have x squared equals 16, and then if you take the square root of both sides, you end up with x equals plus or minus the square root of 16, which is 8. So this would be the solution. So plus and minus 8, right? So the solution set is equal to minus 8 and plus 8. Okay? X squared minus 1 over 25. So this can be solved similar to this, but let's solve it by factoring. Again, just to practice the different methods. So x squared minus 1 over 25 equals 0. This is the difference of two squares, right? Because 1 over 25 is essentially 1/5 times 1/5. Okay, don't be scared of the fraction. You know, should not be scary. It is straightforward. 1 over 25 is equal to 1/5 times 1/5. So this essentially gives us x minus 1/5 times x plus 1/5 equals 0, which gives us x equals 1/5 and x equals, I'm sorry, this is 5. Why did I write 2? So x equals 1/5 and x equals minus 1/5, right? So both of these are solutions. Okay, 2x cubed equals 72x. Again, there's a couple of ways to solve this one. One way could be to bring the 72x to this side, right? And then use the zero product property. Or what we could do is just simplify, right? So divide both by x. So you get 2x cubed equals 72, and then you can divide both by 2 to get x squared equals, so 72 divided by 2 is 36. So now x is plus or minus the square root of 36. So x equals minus 6 and plus 6. Okay? X cubed, x squared plus 2/3 x plus 1/9. This is not an equation. It is an expression, right? There's no equal something. But if you get something like this, you get an expression that does not have an equal sign, and you're asked to solve it, right, or find the roots or find the solution, it is the same as, as if you had a full equation which equals 0. Okay? So keep that in mind. Don't get thrown off just because it does not look like an equation. Okay? You are to assume that it is an equation equals 0 and just solve for the roots. So this can factor out to, so the x squared factors out to x and x. The 1/9 factors out to 1/3 times 1/3, right? So 1/3 and 1/3. Since we have plus and plus, so we should have plus and plus. So this is basically a perfect square, right? Because if we did the FOIL method, so 1/3 x plus 1/3 x is 2/3 x, right? So now we got the middle term. So we could have just said x plus 1/3 squared equals 0. Okay? In which case, x is equal to minus 1/3. This is the only solution. Okay? Hopefully this was clear. This is it for this concept. See you in the next video.